In this exercise, we will cover both NAT and PAT. We will use PAT or dynamic NAT on this router right here, and we will use static NAT on this router right here. By the way, you might recognize this topology. It's the very same packet tracer file we used in our multiple area OSPF exercise. Only this time I configured EIGRP on these routers. And what I should mention is that I configured EIGRP to advertise all networks that you see here, except for these two private networks, 192.168.0.0/24 and 192.168.100.0/24. The reason for this is that when you use NAT, when you want to represent these private networks through a public IP address to the outside world, then it doesn't make sense to advertise those private subnets into the routing protocol, whichever routing protocol you use. Let me also explain why I'm using dynamic NAT here and static NAT here. This network right here, the network of servers, it's behind this router data. I wanted to point out that this is kind of a data center with naming this router data. And the reason why we want to use static NAT here is because we want these servers to be accessible from the outside, and we also want them to have a static IP address. If we were to use PAT here, we would only have one IP address, and if you wanted to ping, for example, that IP address, you could do that from one of these PCs or one of these PCs, but this router wouldn't really know what to do with that packet. The packet would only reach this public interface right here, and then it would go back. Like this, we're going to allocate, or NAT is going to allocate public IPs to these servers, and we will know, since we will configure it manually, it will be a static configuration, we will know exactly which public IP will belong to which server. As for this local area network right here, for end user computers, it's not really that important to have a static IP address. Actually, those are the situations where you want to save public IP addresses. So we will have private IP addresses configured on these PCs. Actually, they already are configured. They're 192.168.0.10 and then probably 0.11 and 0.12. And then all of these computers will be represented on the outside by a single public IP address, and that will be the IP address configured on this interface right here. Also notice that on this link we have a /30 subnet mask, which allows us to have only two IP addresses that we can allocate to an interface or to a host. Obviously, those two IP addresses are allocated to these interfaces right here. First IP is here and second IP is here. In this network right here, we have a /24 subnet mask, which is very convenient for us because when you do static NAT, you have to have enough of public IPs to use for translation from the existing private IPs. Let's start with the configuration then. I'm going to start with dynamic NAT, command line interface, enable configure terminal, and then we want to create a standard access list. Luckily, we've learned about access lists recently, so I hope you remember how to do it. So it's IP access list standard, and then I'm just going to say 1. And then I want to specify the range of IP addresses that should be translated by NAT on this router. I'm going to say permit 192.168.0.0, and then /24 subnet mask in wildcard mode is 0.0.0.255. And that's pretty much it. Let's configure the NAT translation. It's going to be IP NAT inside source, and then we have several options here. we can say static, but we don't want to use static NAT here. We want to use dynamic NAT. So we need to use a list of IP addresses as a source. So these are the private IP addresses which are inside of a network that we want to translate into something public. So I'm going to say list 1, and then what we want to translate those IPs specified in this access list into is the IP address configured on interface fast Ethernet 0/0, and then we want to say overload to make sure this router understands that all of the IP addresses in this list should be translated into a single IP address configured on this interface. Now we are not done. We need to tell the interfaces that are actually receiving and sending those packets whether they are on the inside side of NAT or outside side of NAT. So interface fast Ethernet 0/0 is on the outside side. This is the public part. So we're going to say IPNet outside. And on interface fast Ethernet 0/1, we're going to say IPNet inside. That's it for this router. Let's go to router data. Enable configure terminal. Now I want to be able to see the topology here. So with static NAT, we are simply creating a translation table. So we want to use one command per private IP that is going to get its own public IP. I'm going to say IP NAT inside source, and then I'm going to say static and list the inside IP address that I will be translating into an outside IP address. And I'm going to start with the gateway IP address. I want to translate that as well, not just the servers. So it's going to be 192.168.101. And let's translate that into 15.0.0.11. In this 15 subnet, we've only used IP addresses 15.0.0.1 and 15.0.0.2. So, but we have this /24 mask. We can use any of the 254 IP addresses. So let's use 11, and then I'm going to, for the server, I'm going to use 12, 13, and 14. I'm going to use the up arrow. The next IP is going to be 12, but 192.168.100.12 is the private IP of that server. So this is the private IP of that server, and this is going to be its public IP address once the packets leave this private network right here. All right, repeat that command, switch 12 to 13 on both places, and then do the same for 14. And that's it. The only remaining thing to do is to tell the interfaces whether they're inside or outside. Again, fast Ethernet 0/0 is outside, but fast Ethernet 0/1 is inside. And now we're really done with configuration. I hope you found that to be rather simple, as it was. Let's now test. We can't use this GUI option in Packet Tracer because what will happen if you click, for example, on this computer, the source IP will be the private IP address of that computer, which is 192.168.0.10, I think, yes. And then if you were to click on this server, since this is how Packet Tracer works, the destination IP will be this private IP address of the server. Remember, we don't know the private IP address of the server as a I was going to say customer, but user, right? We could ping, for example, from PCA to PC01, and we can look at the simulation to see how that works. So basically, the source IP here is going to be the private IP address of PCA. Let's check that. Yes, it's 192.168.0.10. And then when we get to the router, on the incoming interface, it's still 192.168.0.10, but we haven't NATed that IP address yet. And then once this packet goes through the router, its source IP address changes from the private IP address into the public IP address, and this is the address of the interface. And then as this packet travels through the network, it gets to the PC. The PC now returns this packet. Let's intercept the packet here. We can still see that this packet is headed toward this LAN router with IP 11.0.0.1. But then when it reaches the router on the outgoing interface, we can again see this private IP address. So as long as the packet is inside the private network, the private IP address will be used. And then once it goes through the NAT router in the outside world, it's going to use the public IP address. You can actually see some statistics on the NAT router by typing in do show IP NAT translations. And you can even see the ports that were used. There's also a command statistics, but I can't use a tab here. And then I can see total translations. So this was probably the 3 ping attempts that we made. Okay, now to test communication between a PC and a server. So we can't use this GUI option that Packet Tracer has, but we can get into command prompt and say ping, and then we're going to use the public IP. So the public IP of this server, for example, or let's use the web server because that makes more sense. I'm going to say 15.0.0.13 because that's the public IP address of that server. And then probably a few of the first pings are going to time out, but then we should get some success. There it is. I'm going to issue this command again so that we can catch the packets in simulation mode. I'm going to say ping again, and here's our ICMP packet. Again, we'll be using the private IP address of the PC, which then translates into the public address. And then we follow the packet all the way to the NAT router, the data router. And we can see that source IP is now the public IP, destination IP is still the public IP address of the server, but once this packet goes through the router on the outgoing interface, we will see that the destination IP has changed from the public one into the private one. And then the packet is successfully delivered to the server, and then the server returns that packet. And we will see that the server is not aware of the private IP address of the sender. Okay, it's returning this packet to the public IP address 11.0.0.1, and source IP is 192.168.113. So it's pretty much also not aware that this server's IP address is actually a different one outside of this private data center network. We can watch the packet go back, and the ping was successful. And that's pretty much it. The one thing I really hope you will take away from this exercise is the fact that when you're configuring a routing protocol, whether it's an internal routing protocol or an external routing protocol, you do not advertise private IP addresses. So if you have NAT, right, you will advertise the public IP addresses you're using or the public IP addresses you're translating your private IP addresses into. but you do not advertise your private IP addresses. Of course, if we're talking about an autonomous system where you entirely use private IP addressing, within that autonomous system, of course, you can use a routing protocol and advertise private IP addresses. But to the outside world, to the internet, we don't advertise these private IP addresses. Okay, that was pretty much it. See you in the next exercise.